Hello, welcome to day 2 of geometric mean problems. We're gonna ramp it up a little bit as far as difficulty is concerned. So here we have again the theorems. The leg is the geometric mean, which means it's going to appear twice of the entire hypotenuse, the whole thing and the piece that's next to it. And then the altitude is the geometric mean, so it appears twice across from each other, of the two pieces of the hypotenuse, so this piece and this piece. So we can use a piece of paper or notebook to measure the height of a building, so you don't have to climb it or drop, a tape measure down it. You can actually use a piece of paper. So what you would do is line up the notebook so that when you're looking at the bottom edge and the top edge, it aligns perfectly to the building. So you may have to step closer, step back, but you can do that against each edge. You put your eye in the corner right there, and what you've done is you've created the special or right triangle with the altitude dropped. So like in this case, this is the altitude right here. So your eye is 5 feet off the ground and you are 10 feet from the building. So 10 feet from the building would be down here. Where does that translate in our picture? That altitude I was just talking about. Your eye is 5 feet from the ground. So that would be this distance, right? Because if this is 5, if I transfer that to my triangle, the 5 would be right there. So now what we want to find is this piece, x, and when we find it, we're going to do x plus 5 to get the entire height of the building. So which geometric mean are we going to use? Well, I don't have the legs. The legs are right here of the original triangle. This leg and this leg, I don't have them, so I'm going to use altitude. So the altitude 10 is going to appear twice across from each other of the two pieces, 5 and x. So 5x, when I cross multiply, is going to equal 100. X is going to equal 20. So if the height is x, 20, plus the 5 that my eye was above the ground, I know the height of the building is 25. The last notes, I warned you, I said there's going to be times we're going to have to do both theorems with the legs and the altitudes. Here's an example of that. We have 3 different measures that we want to find here. We want to find x, y, and z. So looking at this problem, you have to figure out which geometric mean are we going to use. Well, the legs are the geometric mean of the entire hypotenuse, and not going to do that one because I'm missing 2 variables. Same thing here. Z would be the geometric mean of the entire hypotenuse, can't do that. So we're not going to go with legs. Instead, we're going to do altitude. So the altitude is the geometric mean, so it appears twice across from each other, 12 and 12, of the 2 pieces of the hypotenuse, so 9 and x, because those are the 2 chunks that are created. All right, let's cross multiply. You get 9x equals 144. X is going to equal, when I divide both sides by 9, 16. That's how we get that value. Now that I know what x is, I can use the leg theorems. So let's find y first. If I did y, y is the leg. Leg is the geometric mean of the entire hypotenuse, which is going to be 9 plus 16, aka 20. Sorry, I was muted. And the piece next to it, 16. So y squared is going to equal 25 times 16. Now I'm not going to multiply them together because I see that they're both perfect squares. So when I square root these, I'm going to have the square root of 25 times 16. This is equal to the square root of 25 times the square root of 16. I could do this with multiplication, not addition. Some of you do this with addition. That's just wrong. So y is going to equal 20. Boom. Last one, z. Z is a leg, so it's going to be the geometric mean, meaning it appears twice across from each other, of the entire hypotenuse. It's still 25, and the piece right next to it. So I'm going to get z squared equals, and again, in my mind, I'm like, perfect squares. I'm not going to multiply these 2 together because I'm going to have to just simplify them in a second. So z is going to equal the square root of 25 times the square root of 9, because I could separate multiplication this way. This is going to equal 5 times 3, aka 15. Boom. Okay, let's try another one here. I need to find A and I need to find B. So the legs are A and B. So A is the geometric mean of the entire hypotenuse. Got it. And the piece right next to it, 2. Got it. So let's write our proportion. A, the leg, is the geometric mean. The entire hypotenuse is 6. I add those two lengths together. And 2 is the chunk next to that leg, adjacent to that leg. So A squared is going to equal 12. A is going to equal the square root of 12, which is also known as 2 root 3. And then B is the leg, so it's the geometric mean, meaning it's going to appear twice across from each other of the entire hypotenuse. The entire hypotenuse is still 6, and the piece of the hypotenuse next to that leg, so 4. 4 is next to B, 2 is adjacent to A. All right, so now let's cross multiply. B squared is going to equal 6 times 4, aka 24. This simplifies to be 2 root 6. And the reason is, again, because this is square root of 4 times square root of 6. Square root of 4 is 2. And then 12 here, I didn't show it, but it's the square root of 4 times the square root of 3. The square root of 4 is 2. Okay? All right, that's it. The practice that you're going to work on is more challenging. There's more steps to it, more variables you're going to have to solve for, but we will get through it. Okay? Thank you so much for watching. Have a great day. Bye.